Hello everyone. Today we are going to solve the problem missing in array. So it is a difficulty easy question and it is selected from the top array problems list. So the question is, you are given an array ARR of size n-1 that contains distinct integers in the range from 1 to n. N is inclusive. So this array represents a permutation of integers from 1 to n. With one element missing, your task is to identify and return the missing element. So if you see in the first example, the input is, you can see the given array is 1, 2, 3, 5. So they said that they will include the integers all from 1 to n in a array of size n-1. So actually what are the elements should be there? 1, 2, 3, 4, 5. So the 4 was missing in the given input. So the output was 4. This is what they gave in the explanation. So in the second input also, they gave in the unsorted array. So there are multiple ways. So if you see in this example, 1, 2, 3, 4, 5, 6 is missing. And again if you see 7, 8. So except 6 in between, all other were present. So the output is actually 6. That is the answer. But if you see in the third example, the array size is already 1 and the element is also 1. So if all the elements are there and none of them is missing, so we need to return the maximum element from the array plus 1. Means from this array, what is the maximum element? It is 1. So 1 plus 1 is equals to 2. Means increment by 1 the max element from the given array. So that will be the missing element if there are no missing elements in the given input. That is how it works, as the gave here. See, if the input is only 1, or let us say if the input is 1, 2, then the output will be 3, like that. So there are the given constraints and other things. So we can see it is asked in most of the companies like Flipkart and product based, service based many companies. So it is a top array problem. So we can see. So how can we solve? So there are multiple approaches. So one is using the sorting approach. We will sort the given array and check sequentially, but it takes around n log n time as per the given inbuilt method. But we can see expected time, the strictly mentioned time will be big of n. So during the coding, if you can't form any logic which satisfy the both complexities, the time and auxiliary space, so first try to satisfy the time complexity, which is main, and then try to satisfy the space constraint. So as per our logic we are going to discuss, we will not use the sorting approach as it takes n log n. So what is the alternative approach? So we can use a hash set. It is a unique value set. So using a hash set, our space may be big of n, but our time will be reduced to the given one big of n. So that is the approach we are going to use, the hash set approach. So how we will be using? So simply things used. So these are the things we are going to use in the above program or the logic. So a hash set, for loop, some if condition, mostly that's it. These are the things we are going to use: a for loop to iterate the given array, if condition for the later approach, so to checking the element is present or not, and the hash set. So these are things we are going to use. So how to use them? So first we will add steps in our algorithm. So what are the steps means? We will add all the elements to the array. So after this, we will again using a for loop or a for each loop, any other thing, for each loop, simpler purpose. So after that, it is step 1. So step 2 is again use for loop from 1 to n or max. Here we will mention a variable max. The variable name we are going to keep is max. So this max variable will track what is the maximum possible value in the given array. So we see in the first example it is 5, 8 and 1, like that. It will track the max value, which is the max value in the given array. So in this loop only we also find the max value. So both the things we are going to use and initialize using the first loop only. So the second loop we will run from 1 to the max value, and we check if the current value, let us say it is I, like for I in int equals to like that. So if the current value is not in the set in which we added the element, so if not so as we know that all the elements present in the array will be there in the set after we add them. But if they in the for loop iteration, if any element is missing from the 1 to the max element, so what does it mean? So that is the missing element in the given array. So this handles the case where the missing element is present, means the missing element is actually true in the between the of array. But there is another case like we see in this third example, which is the array is only 1. So for this one, our only 1, 2, 3 steps will work, but we cannot give the output 2. For that, we should do a simple one. We should give the output as max value plus 1. Means after going through all the 1 to max elements, we found each and every element in the set or the given array. After that, if all the elements are present and no missing element is present, then what did they say? That means the max element plus 1, it will be 2. Means if there are 1, 2, 3, the missing element is 4, like that. So for that small case, we are using this fourth line. So we use 2 times the for loop and a single hash set to store the values. We are only using hash set because get operation of set takes constant time. This is the one reason we are going to use a set, and also it takes and only unique values are stored, as we know. But the main thing we are going to use this is get operation of set takes constant time. But other collections like the array list or a simple array, also the given array, in the get operation will take around, using a binary search or linear search, it will take a big of n, minimum to or big of log n using the binary. But for that also we need to do the sorting. So again it takes a approx n log n time. So it is not efficient. So that is why we are going to simply hash set, because the get operation takes the constant time, and also the unique values only are stored rather than the duplicate values. Two for loops are used, a one single if condition and a variable to simply track the max value in the given array. So these are the 4 steps we are going to use. We will store the values, find the max element using a one loop, and we check for any missing values in between the 1 to max range, including the max range, using the another loop. So if all elements are present from 1 to max, we use the fourth one, the fourth step, written simply the max plus 1. This is a simple logic we are going to use. So how to do it? So as we said, we are going to use a hash set. So how to declare a collection? First, we need to write the collection name, which is hash set, and next we need to mention the type of collection. As we can see, the given array is of int type, so we are going integer wrapper class as a type. Collections only take wrapper classes names as a data type, not the primitive types. So integer, and any name can be given to the set, like set. So how to initialize some new space to any auxiliary space values? So using the new keyword, and again the collection name, and simply in between here also we can write or we can ignore the type, but here it is mandatory to declare the type of the collection. So the set is declared. So next we said we will use a for each loop, and let's suppose num from the given array. So for each number from the given array, what are we going to do? As we said, we just add that into the set, and also we check with the max that if the current value is greater than max, or already the max value is greater than the current value. Like that we keep on checking until the maximum possible value from the given array is initialized into the max. So before using the max, we need to declare the max variable. Let us say we initialize with the 0th element or the first element of array, or we can use the integer dot min value also. It is simpler. So max is equals to, we have a math class in which there is a max method. We need to compare the values max comma what is the current number, it is num. So afterwards the one for each loop is over, in which the initialization of max variable and the set both are over. So the second loop, in which as we said we are going to go from the 1 to I less than or equal to, because they said 1 to n, the whole range is inclusive. So I plus plus, I is equals to 1, I less than or equal to max, I plus plus. So in the loop, what are we going to do? So for each element I, the current element, we need to check, as we wrote here, we need to check if it is present in the set or not, or in the given numbers or not. So how to check? If the set does not contain, there is a method called contains, which takes a constant space and checks if the given number as a parameter is present in the set or not, which one we declared. So what is the value? It is I. So if the current value I is not containing or present in the set, the not symbol, then that is a value which is a missing value. So simply return the current value only. So if this entire loop is successfully completed and no missing value is sent as output, then that means the whole array is having all the elements without any missing values. So the simply the output will be, as you declare, the max plus one value. So these 4 steps using these things was converted to this code. You can say it is a Java. So if you compile, I think the small brackets issue. the comment I wrote was incorrect. So this is the actual writing way of multi-line comments. The code was correct, the comments was wrong. This is a way to write the multi-line comments in Java. So we can see the sample test case is passed for the case. So if you submit the solution, so the solution is passed, all the hidden test cases. So if you check the time complexity, this loop internet does not contain any again big of n methods or any loops, so it takes big of n. And this loop also, as we said, the contains method, also the add method, both takes big of n. So internally in a big of n loop, there are only big of n statements. So again it is big of n, and all the lines are big of n only. But this space simply takes big of n, which is a small drawback of this logic. So if the final time is big of n plus n, which is also equal to big of n. So the time will be big of n of this logic. Simply it is big of n. So the time is big of n and the space is big of n. So if we compare this with the given complexity, the time is absolutely matching, but the space is big of n. So it is acceptable. As you can see, all the test cases are passed. So this is the approach, and this is the solution. Also, we found out the time and space complexity of our logic or code. So this is how to solve this program missing in array using the big of n time complexity. So practice the program. The program link is given in the description, the problem link. Go and practice it. Thank you for watching.